blender. I said that Kicad couldn't arrange footprints, or at least I didn't remember it. And this is Kicad 5. I've not really used Kicad 6 much now that I've been doing Altium stuff. But for some reason, yeah, total brain fire. I've used this a million times. Let me show you. This is Kicad 5. I'm going to select 3 resistors. Yeah. And right click, align to top. And now they're all pretty aligned. So Kicad could totally do that. I'm positive, or almost positive, 6 could do the same. So I wanted to correct that blender. So now let's go look at... Yes, it's Sunday morning. I'm wearing a white shirt, and I'm a little bit hungover. It's just the way of the party animal. Okay, so I wanted to show you where I'm at with this. I have a few updates with the max reading light LED. LED reading light. I went ahead and decided, as far as the lid is concerned, I just tossed a rectangular lid at the moment on, nothing too fancy, and immediately I regret not going full bore on my 3D model. I mentioned we're doing the fader. Let me switch to the other button there. So we mentioned we're doing this fader thingy, and it's got a linear potentiometer, and it's got this little cap thingy on the top. I wish I would have modeled that, because I basically, for a step model, Fusion 360, so I would know how wide this is, because now when I'm looking at Fusion, I'm going to have to move these faders together, and I'll show you why here in just a second, but it would be nice to have these caps on. Now, it's obvious just by eyeballing it, I got quite a bit of space in there. And if we take that lid off, I could smash these faders quite a bit closer together. However, I've got, as you can see, I've got a mounting hole here, here, and here, so it has to be wide enough for that M3 hole and the screw that will ultimately go in there. So that's a concern, but not a huge concern. And maybe I could smash these guys close together, ignore the the middle one, maybe, if it's a big issue, and just move the screw holes over to this right side. Because here's the big deal, is I decided the way I was going to mount my lid. That was my thing I didn't think of last video. I was like, how the hell am I going to mount this stupid lid? Well, I decided just to put the lid on top, nothing too fancy, and then we'll put screws in it. And maybe I'll recess those later. We can get prettier. We'll think about it later. But the problem is there, of course, thickness. I got to pay close attention to the thickness of this dimension right here, like how tall the lid is, because of how that would interact with the fader itself. So blah, 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 it never ends. That's the whole point. That's what makes it fun. Now, can we see in there? Because I'm worried about the lid actually hitting these faders. Let's turn this lid off. Yeah, I'm pretty close there, but you could see, I don't have a great way to measure like the distance from the fader to the lid, but it looks like we got, well, hell, maybe none. I need to go back to the drawing board on that? Maybe. We will think about it. Now, this is another issue that I'm fairly new to doing 3D models on my own boards. This is one of the reasons I'm doing this. Let's turn the opacity down on this case so that we can get a better feel for where we're at height-wise. And I want to show you something I'm still kind of working out in my own head. And I'm pretty sure I'm just going to have to iterate my way out of a mess here. So I'll say this is the case. All right, so we'll turn this case body, right-click, opacity control. Let's go down to like 20%. What? There it is. Okay, so it's barely on. Okay, so right now I'm basically flush, it looks like. However, look at the bottom of this PCB. Let me turn the case off. So if you look at the PCB, I modeled these long legs because I was just exactly matching what the device is. So let me show you that. So you got these long. You can see, getting closer. How do you do this? You guys know how to do it? Well, it's out of focus. I don't have to tell you people, but okay, that's pretty good. Let me put it on my nose. Anyway, so man, that's weird. So they're long and they're going to get cut. But let me kind of show you what they look like inside the PCB. I mean, you're going to lose, what, 1.6 millimeters and some change. Well, it looks like it looks like the, I can't really do it great. This is not turning out well, but man, this is hard to show you. But either way, they're going to be trimmed some. So these are too long. But also, I say they're too long, but we know full well that this fader is not going to be perfectly flat with this PCB. There'll be space there. And is that a millimeter? Is it half a millimeter? I don't know. So anyway, these kind of clearances and tolerances need to be accounted for. But for sure, I'm going to cut these. There's no way I would, if this was the case, that I would let this length, you know, be hanging out the bottom. But I decided to leave them, and I'll tell you why. And that was because over here on this RJ45 connector, sorry, actually can't see that. We are learning as we go, folks. This is a piece of shit series. I don't think it's going to get any better, though, so let's just run with this. So what I was saying was, if you look at the length of these pins hanging out from under the board, even if there is some spacing, yeah, like, so let's say this linear fader is actually a millimeter or so off the board because of real life stuff, bumping into things. And remember, I don't think I told you this. I did not have a model of this. I made this little, you know, half-assed. It's a rectangular prism. You know, I just kind of threw it together. So the dimensions are basically right, but there's probably stuff on the bottom that might bump it up a millimeter or two off the board. So I got to think about that. But at the moment, it looks, that says 5 millimeters for the whole shebang. This PCB should be 1.6 millimeters. Whoa, it's not. See, this came out of, this was the Altium. That's weird. This is the Altium PCB thickness. I'm gonna have to look into that, I guess. It's only 0.4 millimeters. If you look down the bottom right, I guess my freaking face is in the way. Here, let's move it. So just so you guys know. Hey, there I am. Well, it's pretty small probably for you, but either way, it says the length of this line right here, the thickness of the PCB is only 0.4. So that's 1/4 of what it should be. That throws the game off. Trap for young players. So that's a lesson learned. I'm going to have to figure that out in Altium. We'll do that soon. But what I was going to say is the thickness, or of the what's the right word? The height of the thing sticking out the bottom of the board from this RJ45. This is a real deal model I got from a real deal place. These guys, Amphenol. There they are. Cheat. So that explains why these look huge, because you lose total scale. You have no ability to maintain perspective when you're doing PCB work. You know, a little 06, 03 or 04, 02, 02, 01. These tiny little SMD parts look regular until then you in real life you realize they're the size of a pinhead or whatever. But so anyway, so you got to rely on dimensions. Well, these standoff. What do you call these things? These plastic plugs, and even the pins looked huge, and I couldn't really figure out what was going on there. Well, it's because I've lost total scale, because the PCB is 1/4 the size of what it should be. It should be, way thicker. So anyway, this is kind of where we're at. What I'm going to have to do is make some judgment calls on the bottom. So the pins can be cut, obviously. So we'll have a better perspective when I get this PCB, the correct thickness. But these little plastic dudes, I mean, I guess I could cut them. Basically, I'm not real sure how much height I need here. And so at the moment, the case is flush with the top of these linear potentiometers, as you'll see when I turn this on, and this on, and this on. There we go. Yeah, it's barely. Let's go back, crank that opacity back up. Let's go to 80%. There we go. So it's pretty much flush, but this PCB might be mounted a little bit lower. I'm really kind of struggling with this right now. I'm going to have to put do some soul searching to figure out how high I should make that. So, but anyway, the bigger thing was I decided just to do regular screws and make the little rounded doodads like this. And for a couple of reasons. One is just because this is cheap and easy in there, and there's no real reason I couldn't do it. Now, there's one way. They're called PIM nuts. Let me go to DigiKey. I learned about these at work. I never heard anybody talk about PIM nuts before. Let's just see. I guess that's what. Shit. Oh, the old trick, like I showed you last video. Let's go to Google, and it's, I'm gonna call them standoffs. That's probably a better word. This isn't exactly what I'm looking for, because PIM, I see a picture of it. Let's go there. So yeah, PIM engineering. The one I want to show you is, that's not a bad one, but it's a thin one. What do we got here? Here's the one I'm looking for. Here, let's go back to DigiKey and look for PIM standoffs. Because you can have these SMD standoffs, so you can mount AFC, see. All right, let's try this SMD standoffs, because I didn't realize this existed, but you can actually solder standoffs to your board. And this is worth showing you, and here we go. I wish that I was organized, but we're not doing that. We're doing a half-assed, just make it up as we go. Here we go. Perfect. All right. So in case you guys didn't know, because I didn't know, and I know everything, I guess. Is that the assumption? No. So anyway, this is just an SMD. So you'd make one pad and you'd solder this directly to your board, and then you can put a screw in there. So you could actually mount your lid directly to your PCB. Now there's, hardware strength issues you got to, think about. How much of a beating is this going to take, and that means you got to get your height just right. But it's another way to go. Of course, they're $1 a piece, so that they're not cheap. But it's a way to go. So food for thought. I want you guys to know about it because I'm glad they exist. I don't know if they have those on AliExpress. My gut says yes, but who the hell knows? All right, so back to where we are here. What I'm going to have to do now, since I've decided just to go with a 3D printed version for these holes, and again, that's got its shortcomings. I guess I could put brass inserts if I felt like it, but my experience with brass inserts has been so-so. It's hard to get them in straight. And I don't have a gadget to force, like a little tool jig to force them in straight. So right now, this fader is smashing into there. So this fader needs to go to the right. And, but not by far. If I had to take, how wide is that? The whole thing is 9 millimeters. Let's just estimate it. I need like, let's say 3, maybe 4. So 4.5 would actually be here. It was like about 2 or 3 millimeters would get me. So if I cut off, a millimeter from each spot here, each space in between, we should be okay. Worst case, since this is going to go over here, maybe a mounting hole could go on this outside edge where after this fader is moved to the right. So we're going to have to see how that goes and see if we can still fit the parts we need in there. Now, this is something else to think about down the road. I went with 100 millimeter resistors. You can see them there, and there. That was part of my little, what did I call them? Separator. Let me go to the schematic. Yeah, see the separator resistors, this one, these top 5 here. Well, what if something happens and I decide I want a different value? Well, I can't get my damn soldering iron in there. So this is kind of a bad practice. It's good to keep them close to the, to keep your traces close, but from like a practical standpoint, if I have to solder in there, or even get a heat gun in there because this is SMD, I don't have any of those tweezer things where you can reach down in there and clamp them. So I guess I could stick 2 soldering irons in there, but even then I'd probably hit the side of this plastic case and melt it. So if something were to happen, then what's my plan? Now, of course, I guess I could take the circuit board out, but the PCB is removable because we're just using screws. We're going to go in these holes eventually. So that's a tricky one to think about too. So at the moment, I'm actually kind of thinking maybe I should put these resistors down here, even if that means my traces are much longer. Now, this is a topic I struggle with because I read these books about signal integrity and low noise, and they're talking about, 10 gigahertz signals, and this signal is essentially 0 hertz. We're DC. We're running 3 volts to these guys, and they're going to have a different DC voltage. I guess you could say it's not DC when you're actually wiggling the fader, but you don't care about that. So because this is just DC, there's the rule. It's as easy. The rules are basically nothing, and we don't even care about noise because we're going to filter that out on the brain before it goes to the ADCs of the SP32. So long story short is moving these resistors down here so that I can actually solder and work on this damn thing has extreme value. And it's real easy to get your head in this place of using rules that apply to, like, say, a 10 gigahertz board or whatever. And then suddenly you can't work on your simple little voltage divider. So I'm bad about that. It's a bad habit where I'm going to design something for a Raspberry Pi. And then here we are doing Pee-wee stuff, and I make life much harder on myself. So I think that the resistors are going to need to go down here just so I can work on this stupid thing. And these are the kind of things you don't really notice as much until you actually throw it in a case, or in this case, throw it in a case in a Fusion. So I recommend you when you're deciding a lot of electronics, or at least PCB layout type issues, you throw it in a Fusion 360 model first just to get a feel, because you're going to notice all kinds of things. And ultimately, I would say the 3D modeling part, the mechanical part, is probably harder than lots of electronics, at least when it comes to this, basic electronic stuff. I guess it all gets hard if you go into the big leagues. So anyway, we're going to take this fader, we're going to smash it that way. We're going to give it more space and maybe move some holes that way. And we'll come back and see how it turns out, and we'll have new problems, I'm sure. We'll solve those too.